Good evening, ladies and gentlemen, and I'm delighted to welcome you to this evening's event. This is a virtual tour of Éireann Éireann Irish Rail's Limerick depot. This is a joint event of Engineers Ireland's Mechanical and Manufacturing Division, Thomond region, and the Republic of Ireland region of the Institution of Mechanical Engineers. And now I will hand over to Professor Orla Feely, President of Engineers Ireland, to open this evening's event.
Thanks very much, Diarmuid. And it's a great pleasure to be with you this evening, and great pleasure to see so many of you joining us in such numbers for this evening's event, which I think is going to be really interesting and really important for a number of reasons. First of all, it showcases the excellent work being done by Iarnród Éireann in their Limerick works. I know a number of you are very interested in that, so you'll be able to find out lots about it. In addition to that, it's also somewhat of a trial for us following the virtual sectors initiative of how we can make these virtual site visits work for us. So this has been the subject of an enormous amount of work by those involved, pulling together the technology and the people needed to deliver what we think will be a really, really interesting and engaging event. So thanks to all who undertook that work, and it showcases for us, it's the first, I hope, of many virtual site visits that can be used in events such as this, in CPD, in all forms of engineering education, in enabling site visits to places that one couldn't normally get to. So I think the opportunities here are immense. I think it's one of the positive side effects of the pandemic that we are all more open to such events, and I think it's great to see, and I'm really looking forward to seeing how this works this evening. Before handing over, I have a few people I want to thank. Foremost among them is Peter Smith, who's Éireann Éireann's Chief Mechanical Engineer, who has been enormously helpful in relation to this event, making his time, his expertise, his people available to us, and also opening the doors of the Limerick Works for this virtual site visit. Now, very, very sadly, Peter suffered a significant family bereavement over the weekend, so he's unable to be with us now this evening as he had really planned and hoped to be. He was kind enough to talk to me yesterday when I passed on all our condolences. And again, he reiterated just how very strongly he had wanted to be part of this evening. But he has asked Chris McMorrow, Éireann Éireann's head of fleets, to represent him here. And I know that Chris will do an excellent job. So condolences to Peter and great thanks to him for all that he did. And there are a number of Peter's team in Limerick and Inchicore who also contributed a huge amount to proceedings. That's Pat Roach, the fleet manager for freight, Mark Carty from Inchicore Fleet Technical Support, and Donncha Stackpool, whom you'll be seeing in a few moments, who's the star in the videos, and he's the Assistant Depot Manager in the Limerick Works. A particular thank you to Éireann Éireann's filmmaker, Emma Cuddy. Emma did an awful lot of work coordinating all the filming, the sound recording, the editing, the drone footage from Michael Fitzpatrick. I know she was a huge contributor to what is going to be happening here tonight. So Emma, thank you very, very much for that. I want to acknowledge the work of John Byrne, who many of you will know, formerly with Engineers Ireland, who did a lot of work in support of this virtual sectors initiative. So I think what we'll see rolling out is a great tribute to that project, and thanks to John for his work on that. Finally, thank you to those involved from the sectors, from the regions, from the divisions, all of those who've been so inspired by this project and put so much work into it, in particular Diarmuid and John Coleman, with whom I had an excellent meeting a couple of weeks ago on this, where they really conveyed their enthusiasm about this project and the great promise that it holds for us as an organisation. So now all I have to do is to hand over to Chris, who's going to take us through the next stages of the event. So again, thanks for joining us, and over to you, Chris.
Good evening. Good evening. You're all very welcome. We're absolutely privileged to be able to showcase the good work we are doing in Limerick, and coincidentally, we are marking our 175th anniversary, and Limerick itself has been a cornerstone of the Irish Railway throughout that time. Just a brief note before we go into the presentations. Limerick would be the centre of excellence for wagon maintenance in Irish Rail and diesel multiple unit maintenance in the west of Ireland. Interestingly, the 2600 fleet itself was the first Japanese fleet procured in Europe in 1994. And following the success of that fleet, the company procured the successor 2800 Dmu fleet several years later, which was placed into service in 2001. My colleague Donncha has prepared a short overview of the history of the depot, followed by videos on the diesel multiple unit and wagon fleet. My colleague Mark Carthy is then going to take us through the technology behind our state-of-the-art axle bearing alert and wheel impact load detection systems. So I hope you find this all very interesting, and I'll just hand you over now to John, who will play the first video.
My name is Donny Stackwell. I'm the Assistant Depot Manager here in Limerick Depot, and I've been working for Irish Rail for just over 20 years now. The purpose of my role is a support function to the Fleet Manager Freight, and our function is to consistently meet the needs of Éireann's business by providing freight, wagons and diesel multiple units to our customers to meet timetable requirements and to assure availability and reliability of our fleets. Here in Limerick Depot, we manage all aspects of the maintenance associated with freight vehicles and facilities, and the roles within the depots to ensure operations, tasks and facilities are performed safely, efficiently and correctly.
From 1848, thousands of people have worked in this place, forming the life and soul of the depot, and unbeknownst to the casual passerby, the depot itself covers just over 21,000 square metres, 7,500 square metres of which is enclosed under roof cover. There is also just over 1,600 metres of rail line within the depot, which is used daily for servicing activities and storage of units. Once through the main arch, this place is still a hub of activity today, with workers maintaining and overhauling 2,600 and 2,800 diesel multiple units to service the west and southwest passenger requirements. Support maintenance functions for the passenger fleet is also carried out in Ballina and Cork. Freight and wagon fleets are also fully maintained and overhauled within the works, with running maintenance support functions carried out in Northwall Depot and also with 2 mobile workshops. As we approach the depot on the left, you can see the wagon works, which was built in and around 1870 and has remained virtually unchanged to this day. In the late 1990s, the wagon maintenance facility in Inchicore and Cork were closed, and Limerick Wagon Works became the main wagon repair facility for Iarnród. Constructed in 1848 to serve the needs of the Waterford and Limerick Railway. The locomotives and carriage works was suited to Limerick from the outset, and the works that was constructed in 1848 is almost identical to that which is here today. The wagon repair shop within the depot was built in the early 1870s, and the works comprised of a locomotive shop, blacksmiths, carriage repair shop, wagon shop and sawmill. The works conducted the repair and overhaul of locomotives, carriages and wagons throughout its history, up until the end of the steam era. Locomotives were repaired and maintained at the locomotive shop. But with the arrival of dieselisation, the loco shop was downgraded and routine servicing and minor maintenance was carried out. On your right, you can see the service slab, which was constructed and completed this year. The service slab is a fantastic new addition to our facility, which allows us to carry out fueling, detanking, oil and watering of ICRs, DMUs and locomotives in an environmentally compliant and friendly way. The centre of the view shows the Dmu Shed, or the loco shed as it was formerly known as, which was constructed in 1848. Up to the early 2000s, the locomotive shed carried out minor exams and repairs of locomotives used for hauling passenger and freight rolling stock, as well as exams on carriages used on the local commuter services. After this, maintenance activities changed focus from locomotives in 2004 to diesel multiple units, with the 2700 fleet based in Limerick from 2004 up until they were withdrawn from service in 2012. Currently, the 2600 and 2800 DMU fleets are maintained here today. The depot has a proud tradition of getting things done and has been used for commissioning new fleets, including the CAF 2900 DMUs, the Mark IV push-pull coaching stock, the ICRs, the pocket wagons and the Hobbs vehicles. The works has witnessed big changes in the way maintenance activities are carried out in the past 20 years or so. The industry and the regulatory requirements has changed vastly over recent years, and we have changed how we carry out our work activities in order to comply with these changes. Limerick Depot has NSI certification in Quality Management Systems ISO 9001, Energy Management Systems 50001, Environmental Management Systems 14001, and Occupational Health and Safety 45001. And ECM, Entity in Charge of Maintenance Licensing for Freight and Passenger Fleets. And our most recent achievement, EN 15085, the Design, Manufacture, Testing and Conformity Assessment of Welding on Rail Vehicles. And I believe we are the first company in Ireland to have achieved the standard.
Thank you for that. Very interesting presentation, Donncha. Before we move on to the next one, there are just two parts to the next video. Donncha is going to take us through the 2600 and 2800 DMU fleet in more detail. And then Mark will take us through our acoustic bearing alert and wheel impact load detection systems that are used across all Irish fleets on our network. So John, if you can just take us to the next video, please.
So our passenger fleets currently maintained in Limerick consist of 36 rail cars, which are used to service our customers in the west and south of the country. The 2600 fleet is based in Cork in 8 two-car sets, with 6 sets required to operate routes on the Cove, Middleton, Mallow and Tralee lines, with some services operating as frequently as every 30 minutes. The 2800 fleet is based here in Limerick in 10 two-car sets, servicing customers in the Limerick, Ballina and Galway regions. With both fleets, we have the option of running them in larger consists such as 4-car sets to meet passenger requirements on peak services. The 26 and 2800 diesel multiple units, DMUs, are maintained almost completely out of Limerick. These fleets are captive to Limerick and Cork, and all maintenance activities are carried out in these locations, bar the painting of the units, bogie and wheelset overhaul and wheel turning, which is carried out in different facilities in Inchicore Works. As I mentioned, the 2600 and 2800 units are configured in 2-car sets, which consist of a DC1 and DC2 car. The difference being between both cars is a toilet and the DC1. Each car is fitted with a traction engine with the primary power source delivered from a 14-litre Cummins NTA 855R1 diesel engine that is mounted to an Nakata hydraulic transmission that drives both axles on the leading bogie of both cars. The power output of these engines is 350 brake horsepower at 2100 RPM. Each car also has a generator set which is driven by a Cummins B-Series diesel engine. This engine gives us 73 brake horsepower at 1500 RPM. The alternator is a 3-phase generator with an output of 230 volts alternating current single phase and 400 volt alternating current 3-phase at 50 Hz. There is also a 24 volt DC electrical supply to the vehicles for battery charging and to supply emergency equipment, which is supplied by a low voltage power supply box. All maintenance activities we carry out on our components on the 2600 and 2800 are per as OEM or original equipment manufacturer specifications. For instance, the traction engine and generator engines are removed from the train sets every 5 years and returned to our contracted supplier in the UK for full overhaul. Similar, the transmission sets are sent to a licensed agent for Mitsui, who happens all to be in the UK, to receive full overhaul. Not all components for the DMU fleets are sent to external suppliers or contractors for overhaul. Inchicore Works in Dublin overhaul bogies for all fleets on site and ship them out to the designated fleet owners for fitment. Likewise, wheel sets are built on site in Inchicore and supplied to the bogie shop where they're fitted. They also supply wheel sets to the wagon shop here in Limerick. When the sets are due for a refresh, they are sent to the Fleet Casualty Repair in Inchicore, who look after vehicle painting and body repairs. The A exam is a minor exam that covers maintenance activities such as checking oils, coolants, braking systems and operating systems such as lights, wipers and so forth. We also take kilometre readings from sets at A exams, and the readings are inputted into our SAP system, which we use to programme, track and keep record of all planned and unplanned maintenance activities. Cork Platform Support carry out A exams, which is every 84 hours on the 2600 fleet, and our mobile workshops carry out A exams on the 2800 units in Ballina for the captive sets in this region. These support functions to Limerick Depot eliminates the requirement for transfers of sets back to Limerick frequently. The B exams, which is a kilometre-based exam and is carried out every 11,500 kilometres in Limerick for both 2600 and 2800 DMUs. This is a much larger exam or service, and items covered during this exam would vary over 13 separate B exams. For instance, the transmission is service on every B6 exam, and we have different tasks such as oil sampling or checks which are carried out on some of the other B exams. Typical systems used on the units and maintained during the B exams would be the braking systems, the wheel slip slide protection system or the WSP units, sanding systems, couplers and passenger access doors. The brake system, which is a standard two-pipe pneumatic system, consists of a main reservoir and a brake pipe, and it is a fail-safe system where the brake applies with loss of air pressure. Braking is operated by a service brake cylinder connected to two wheel-mounted brake discs connected to the driver's brake controller. Wheel slip slide protection or WSP units is a battery-powered microprocessor controlling the wheel slip slide protection that is active at all times. This system provides slide correction for the pneumatic brakes. Its purpose is to prevent the wheels from slipping or sliding during braking or when under power. It is controlled via a number of speed sensors mounted on the number of axles on the DC1 and DC2 cars, and each car has its own independent WSP rack. The sanding system, which dispenses sand from the unit onto the rail in front of the wheels for traction purposes. These are mounted on the intermediate bogies or the trailing bogies on each unit. The system takes its command from the WSP unit, and each car can operate during braking, if there is wheel slip slide, or during low rail adhesion, and can be operated by the driver if required. We have two types of couplers fitted to the units. The front end is an automatic electric coupler which enables coupling of units from the cabs. The B end or intermediate coupler is a semi-permanent coupler. The passenger access doors are two double-leafed sliding pocket doors on each side of both of the 2600 and 2800 vehicles. These doors are driver-enabled and passenger-operated via electro-pneumatic systems. They have features such as audible door opening and closing alert, with additional safety with obstacle detection on the door edges. The passenger doors cannot open or remain open if the vehicle is moving greater than 5 km an hour. The units will not give traction power if the doors are opened. The running maintenance budget on the 2600 and 2800 fleet will be around 486,000 per year. This may change over the year and would depend on certain variables such as modifications or upgrades to systems. Again, nearly all our stock for the 2600 and 2800 fleet is kept on site. In terms of the number of maintenance exams carried out on Limerick Depot on the passenger fleets, we will be planning on average around 1100 A exams on the ICRs, 380 odd B exams on the 2600 and 2800, and just over 1800 A exams on the 2800 fleet. As a support function to the Loco Shed in Inchicore, Limerick carry out A+ exams on locomotives. This exam is at 2-week intervals. Again, these are a relatively minor exam with checks carried out on coolant and oil levels, including compressors, governors and battery levels and so on. Minor fault finding and repairs are also carried out on locomotives on site. With the intercity rail cars running between Dublin and Limerick, the depot is ideally located to carry out the fuel point exams on the ICRs as a support function to Portlaoise train car depot. This exam is every 48 hours and all maintenance activities are reported back to Portlaoise train car depot, which is a designated maintenance location for this fleet. This exam would involve brake inspection and underframe checks. We also carry out washing, fueling, detanking or desludging of the toilet systems on ICRs and local services. One of the technologies used to monitor both our passenger and wagon fleets is the Wabtec Track IQ system. The Track IQ system was installed in 2015 with 3 sites across the network, 2 in Dublin, Dublin North and Dublin South, and 1 between Limerick and Limerick Junction. The project involved fitting of RFID tags to all the vehicles for the system to be able to recognise the vehicles when they passed. It is used for railbam acoustic axle bearing monitoring, managed by our fleet technical support team, and the second, wheel impact load detection, managed by production staff in all locations. With the Track IQ system, the general principle of the railbam system is to listen for characteristic acoustic signatures of internal bearing faults using an array of microphones. Mark Carty, one of our fleet technical support staff in Inchicore, will take you through this in a bit more detail.
So good afternoon, my name is Mark Carty and I work here in Inchicore for the fleet technical support for the bogies and wheel sets. So we provide technical support for anything that's related to wheels, axles and bearings for all the depots around the network, and that would include the Limerick depot. So one of the systems that we use to help monitor our bearings and wheel conditions is it's a Track IQ system. The Track IQ railbam is a bearing acoustic monitoring system that monitors the acoustic signature of axle bearings and is listening out for faults within them bearings. Then the Track IQ WCM system is a wheel condition monitoring system that provides information on the wheel tread condition, the loading conditions, the weight of the wheels, the weight of the axles, and it also gives any imbalances of trains that pass the sites. So the railbam and the WCM system are located in the same site, and we have 3 sites located across the network. We've one on the up road at Inchicore, we've one on the down road in Callester, and we've one site at Monard on the single line between Limerick Junction and Limerick. So in a nutshell, how the system really works: an oncoming train will approach the site, and this will sort of induce vibrations into the rail. These vibrations then are picked up by accelerometers which wake up the system, and the microphone cabinets open up and they're ready to listen to the passing train. So as the train comes into the site, there is an RFID tag that is mounted to the underframe, and it is read as it passes the site, and this then gives the identity of the train, the wheel numberings and the bearing locations on that unit. So the bearings then, the railbam uses an array of microphones to listen to the characteristics of the signatures of the bearings, and it's listening out for any internal faults that might be happening. This information then is downloaded in a central server by Track IQ, and they use signal processing techniques to determine if there's a fault, where the fault is, and the classification of that fault. So then the data can be viewed in the user interface, which is the Fleet One database, where all the information is stored, and we can view it then as a technical support team to see if there's something trending on a wheel, on a bearing, and we can then relay this information back to the depots. So I'll just show you a quick video of animation of how the system works. So as I said, this is Track IQ. This is their system that we use. So as the train approaches, the vibrations are induced into the rail, it wakes the system up. Then the microphones are listening to the passing bearings to see and listen to see if there's any damage within them bearings. The microphones will listen to 2 full rotations of each wheel and for anything that might be anomaly within the internal workings. So the video there, you can see that the rollers are passing a bit of damage on the top part, and that is emitting a sound that the railbam is picking up. That information then is sent forward to the central server where it is processed, and then the information then is sent back to Irish Rail on the Fleet One user website. So you can see then that if we had a fault with one of the bearings, we'll get notification, the trending analysis is used, and then we can relay this information back to the depots. Work orders can be generated, and they can plan in then to take the wheel set out, change the bearing, or change the whole bogie. So that is a quick overview of how the system works. So what does the bearings do that the microphones listen to? So there's 3 main characteristics that we listen to in a bearing. With the ball pass frequency for the outer raceway, the ball pass frequency for the inner raceway, and the ball spin frequency. So the ball pass frequency for the outer raceway, it is the rate that the number of rollers within the bearings will pass through a given point on the outer raceway in one shaft rotation. So if we had damage in the outer raceway of the bearing, the rollers will strike that little indentation on the outer raceway and will emit a sound at a frequency that is related to the BPFO. The same then with the ball pass frequency for the inner raceway. This is the number of rollers that pass through a given point in the inner raceway of the bearing in one shaft rotation, or for us it'd be one wheel rotation. So if we had damage on the inner raceway, the rollers will strike that at a certain frequency, and the railbam picks up that information. And the ball spin frequency then is the rotation rate of the rollers in one shaft rotation. So these different frequencies, they will give us the characteristics of the bearing faults. So with the lads in Limerick, they looking after the wagons, and the LPF wagons, they would use a bearing or a Timken seal cartridge taper roller bearing. And that bearing, the HM17446, has different characteristics. It has 20 it has a ball pass frequency outer raceway frequency of 10.3 Hz. the BPFI is 12.7 and the BSF is 4.7. This information then will tell us what is happening in the bearing if there is damage. So if you look at this quick video here, you will see that the blue dot is the BPFO, and you can see the number of rotations that the rollers are striking through that blue point in one rotation. The orange dot is the inner raceway, and that is the rotation of the wheel. So as we see that the frequencies are different for each characteristics, and this is what Railbam is listening for. So the information then that is taken from the microphones is sent then to the Fleet 1 user interface. This then gives us all the information of the bearings of all that trains that pass through the Railbam sites. If something starts to flag, then we'll get a daily email alert sent out to the depots and to the guys here in the technical support for bogies and wheels with potential bearing faults. So these faults then are categorized as severity levels of 1, 2 or 3, being the most severe, 2 being medium and 3 being a level potential fault. And we then have locations of where the fault may be within the bearing. So we have the roller, we have the cone and we have the cup. So if we had an RS2_P, that is telling us that we have a potential fault of severity level 2 in the cup or the outer raceway of the bearing. So this information then is processed, and there's algorithms then used to determine the consistency of an acoustic bearing fault. So the Railbam is smart enough that it can listen to the last 10 passes of that bearing, and it works out the data to see if there is consistency amongst the last 10 passes and if the noise is consistent and it's of the same frequency in hertz. So if the consistency starts to grow, we know then that there is a trending fault within that bearing, and we can then take action. And we then internally use our own CME standard 317 on how we monitor and control such faults. So you can see here now we had an issue in 2020 with one of the wagons. This is on wagon 30137, and we were liaising with the team in Limerick to keep an eye on this bearing as it started to create faults. You can see then that the email came out. It started to tell us that there was something happening. So what happened then was we then looked further into this. We went into the Fleet 1 data to see if there was information on the spectrum graph that could tell us something. So we can see then on that top graph there, the spectrum, there is signal waves that are starting to line up and stack up amongst each other. And we can see that the frequency or the orders of them waves are all around 10.3 hertz. So that is telling us then that there is a potential damage in the outer raceway, because that 10.3 hertz is lining up with the ball pass frequency of the outer raceway. So that gives us confidence then that the Railbam is hearing something within that bearing. So we can then listen to the sound files, and the sound files will give us indication that if there is potential clicking noises, which we like to hear if there's a bearing fault, that will give us reassurance that there is a damage there. We then look at the severity and the consistency of the faults, and if they all line up, we know then that there is a high probability that there is damage within that bearing. So with this wagon, the number of waves that start to stack with each other, we decided that it was the safest option to remove this bearing and have a further investigation. So on further investigation of the bearing, we can see here it was stripped down, and we could see on the outer raceway, there was 3 levels of damage on the outer raceway. So the 3 bands of spalling were found, 50 to 60 mil each side, and then a smaller one that was starting to develop. This damage then was lining up with what the Railbam was hearing. There was hearing damage in the potential in the outer raceway location. So we knew then that when we stripped this bearing, that the damage we found was in fact true of what the Railbam was hearing. So there is reassurance with the system, and then this helps us let the guys know in Limerick that the bearings are being monitored by the system, and if there is any potential damage, the Railbam will detect this. So since the Railbam introduction in 2016, there have been over 50 bearings removed from service due to acoustic bearing alerts. On investigation of these bearings that were stripped down in Lynchicor, we found the majority of damage was found in the outer raceway, and this damage was predominantly spalling of the shell. So this has given us great confidence that the system is detecting what is actually happening in the bearings, and we have reassurance that the bearings are then properly being monitored. The pictures there, then you can see the difference in the fleets that are being detected with the ICRs, the locomotives, the wagons, They've all been detected by the system. So that is an overview of the whole RailBAM system. The microphones are listening out to the bearings to see if there is any potential damage. We can then investigate further to see if this damage is true. And when we have confidence that the system is detecting something there, we take action, remove the bearing. So hopefully now that is a full understanding of the RailBAM system and you have a better understanding and knowledge of how it works. Thank you for listening today.
Big thank you to both Donncha and Mark. Very interesting. The performance of the fleet that Donncha was talking, the 2600 and 28s, continues to actually surpass all our expectations, despite it being almost 30 years old. It's a key reliability metric in terms of mean kilometres between failures, beats other DMU fleets, not just in Ireland, but across the UK and Europe. The acoustic fleet has been a game changer for us in wheel management. The 50 bearing alerts referred to by Mark, actually these defects were notified to us several weeks in advance of a pending bearing failure. This enabled us to actually take the required action, pull the vehicles from service in a planned, orderly fashion with no disruption on the network. So I think we can go on to our next presentation, which will be on the wagon fleet. So I suppose just a short intro. The words Limerick and wagons will go hand in hand. The team have a long established wagon maintenance competence where they have 222 wagons for freight and civil engineering track works. I'd just like to warn you in advance, you may notice a slight sound issue for the first few minutes. So it's nothing got to do with your own computers. So please increase your volume if need be. And John, I'd hand it over to you. Thank you.
So our wagon fleet, we have a total of 415 wagons with 223 in-service vehicles servicing our freight and infrastructure customers. The age of the fleet varies from 1970s up to the newest fleet, the Hobbs vehicles, Hobbs being an abbreviation for High Output Ballasting System, which was delivered in 2010 and commissioned here out in Limerick. Our freight fleet consists of 123 vehicles servicing Boyden, or Tara Mines as they're known, Quilta, and our container traffic, International Warehouse and Transport, known as IWT. Our most recent customer, XPO Logistics, who have just started container traffic between Waterford and Ballina, started with one train a week commencing in September 2021 and plan to increase these services to 2 trains a week by year end. Just to give you an idea of how much product we move for our rail customers, Tara Mines, we operate 3 trains a day, 5 days a week, which equates to 380,000 tonnes a year moved between Navan and Dublin Port. Quilta will carry pulpwood. We can run 4 trains a week from Ballina or Westport to Waterford, which equates to around 85,000 tonnes yearly. The remaining 100 vehicles are used by our infrastructure colleagues for servicing the network. These will be made up of the Hobbs, which I mentioned earlier, the rail trucks, 62'9" flatbed vehicles, the LP wagons, all of which are used for carrying rail panels and spoil containers. On the wagon fleet, we operate both vacuum and air brake operated braking systems. The older vehicles are still running on vacuum systems, with the newer fleets running on 2-pipe pneumatic systems, consisting of a main reservoir and brake pipe. This is a fail-safe system which applies the brakes when the loss of air pressure. The vacuum brake system is also a fail-safe system but operates on a single pipe. When continuity is lost between the train and brake supply. The maintenance plans on the wagon fleet are time-based, with 2 monthly train examinations carried out on both freight and infrastructure vehicles. With that being said, we have maintenance staff at strategic locations just outside Dublin Port in North Wall Depot, and one of our mobile workshops based in Ballina, which also covers Westport. We carry out inspections on vehicles pre-departure, so in theory these vehicles are checked much more regularly in the field. The rest of the wagon vehicles, bar the Hobbs fleet, which I will cover again shortly, are on time-based exams, and we bring these wagons into the depot every 6 months for a D-exam.
6 monthly D-exam. This exam covers structural inspections, component checks, braking systems, drawgear, buffers, inspections on load securing devices, just to mention a few. The general repair, or GR, is also a time-based exam, but frequencies vary depending on the estimated yearly mileage of the fleets. Some fleets receive a GR every 5 years, with other fleets remaining in service for up to 10 years. Just to give you an idea of the volume of work per exam, a 2-weekly exam on a full train, which would consist of 18 vehicles, can be carried out by 1 person in an hour or so. A D exam or 6 monthly exam is carried out by an individual on a wagon, can take up to 8 to 9 hours. That's without waiting. General repairs vary depending on fleet types and variables such as the size of the vehicle, braking systems, bogie types. This exam can take from 2.5 weeks up to 5 weeks for up to 3 staff to complete. The Hobbs Fleet high output ballasting system is unique when it comes to wagons, as it has its own independent power supply and hydraulic system. The generators on this train are used to power the lighting and hydraulic systems on this fleet. In order to maximise the life of the hydraulic system, we use an oil filtration system during some of the exams that is designed to maintain oil in a clear and new-like condition throughout the operational life of the vehicle. The purpose of this process is to remove microparticles from the oil. It removes water contamination from the oil, increases system reliability, prevents system corrosion, reduces component wear, extends oil life and generates CO2 savings and reduces operational cost. The infrastructure department have 3 trains of 8 vehicles with 2 generators on each train set. The maintenance programme on these vehicles is 2 weekly exams, 3 monthly, 6 monthly, yearly, 2 yearly, and preventative maintenance carried out at strategic components every 8 to 10 years. These vehicles were manufactured by Wabtec in the UK and have a Barber Easy Ride bogie fitted in comparison to the Sambermuse VLH2 and VLH3 bogies fitted to the rest of the wagon fleet. The Barber Easy Ride bogies are designed to benefit a low life cycle cost, and features that include high strength cast steel frame for extended fatigue life, passive wheel steering, friction dampening components designed for 1 million miles of service. The design imparts high resistance to damage or frame distortion in the event of a derailment. Composite brake blocks, which by the way have been fitted to all the wagon fleets in the last number of years and move away from the cast iron block. And swivel bearings on top and bottom of brake levers, which allows the brake beams to move laterally to ensure the brake block is always located at optimum position. Northwall Depot, which is on the rail network just outside Dublin Port, carries out running maintenance on the Tara Mines and LX Flats for the container traffic between Dublin Port and Ballina, and the Tara Mines between Dublin Port and Navan. All other maintenance activities are carried out in Limerick Depot with the support of our 2 mobile workshops, bar wheel turning. As mentioned during the segment on the passenger fleets, the wheel sets for the wagon fleets are manufactured and overhauled in the wheel shop in Inchicore, then transferred by rail to Limerick, where we use them building the bogies on the fleet. A typical maintenance programme for Limerick Depot yearly would be on average 30 general repairs per year, 230 D exams per year, up to 5,700 2 weekly exams with 530 Ds on the Hobbs fleet. Also the Hobbs will cover 3 monthly exams, 48 yearly exams and 24 yearly exams. We would have a materials budget of around 890,000 per year, and this will be broken down to around 345,000 for infrastructure vehicles and 550,000 for the freight vehicles. Our stores carries on average €2 million inventory per year, with all material held locally in Limerick for all wagon fleets, 2600 and 2800 DMUs. Some of the biggest challenges we face for both passenger and wagon fleets is the supply of parts. For instance, this year alone we have shafts used for the overhaul of the primary and secondary drives on the 26 and 28 ordered from Mitsui in Japan. The lead time from these shafts is 18 months, and inevitably this will affect our heavy maintenance programme on both fleets. Thank you very much for your time and attention for this virtual tour of Limerick Maintenance Depot. I hope we gave you an insightful look into the activities we carry out here in the West. A big thank you to Emma Cuddy for editing and filming, and also Michael Fitzpatrick for recording the drone footage. I'd also like to thank all our staff on site for their participation and patience in this video, and for putting up with us for asking to be quiet while we carried out a lot of recording. Thank you.
As well. And I think I'll take the opportunity at this stage just to bring the evening's event to a close, and to thank everybody who joined us here this evening. The next event for the Mechanical and Manufacturing Division will be our student competition in the next few weeks, and those student entries will be presented to our members before the end of the year. Just to conclude the evening by thanking everybody for their attendance, and thank you everybody for your participation this evening, and to hopefully we'll see you at the next event.